The objective today is to explain how images are encoded with pixel data. So what could that mean, pixel data? Well, to start, let's do a quick review. It says here a salesperson is trying to sell you a phone that has 16 gigabytes of memory, saying that's enough to record an hour of high-quality video. The salesperson is probably wrong, but in which direction? Would you have more than enough memory or not enough at all? And a great table. You've seen this one before. Some of these things you should probably start memorizing. At least I would memorize the first one, that your typical email is going to be about 15 kilobytes. So in this lesson, you'll begin to explore the way digital images are encoded in binary. And you've seen that word encoded before, especially in the context of our ASCII lesson, ASCII being a number that connects to a letter in the alphabet. So your job will be to invent an image encoding protocol. This will help you understand the subtle complications of encoding images, namely the need for other data, called metadata, that describes properties of the image necessary for rendering it. You will learn about pixels, raster images, and what an image file format is today. Think, Write, Share. What do you remember from our short metadata lesson? And if you can't remember anything, go ahead and Google it and write a small summary of what you find. Image file types have some similarities to data packets we saw in the Internet unit because images must include metadata or data about data. The data of a black and white image is the list of bits that represent whether each pixel is on or off. So very easy. It's black and white, on and off, connects well. To create the image, however, we must also know how wide and tall the image is in order to create it accurately. This necessitates the creation of a file format which clearly defines how this metadata will be encoded, since it is crucial for interpreting the subsequent data of the image. What was the metadata inside of a packet? Well, remember we had to and from information in there. So here's your picture of a packet. It is similar to how an internet packet doesn't only contain the data you need to send, but also include metadata like to and from addresses and the packet number itself. So remember, if packets were out of order, the computer can look and see what number that packet was. And then if it's not receiving a particular packet, it can ask for it again. So here's an analogy. Packet is to image as the to and from information is to the wide and tall information. Think, Write, Share. Does this analogy make sense? Why or why not? You can look at the binary. It won't be very useful, but out of curiosity, it's cool to see. To the left is the binary turned into hexadecimal, so it's a little easier to digest. And actually, sorry, I cut that part of the image off. What you are looking at here are just TCP packets. If you want to see the website I got this from, though, you can go ahead and go to this link. Pretty interesting. Digital images can be stored in many formats, but one of the most common formats is raster. Raster images store the image as an array of individual pixels, each of which has a particular color. Higher quality images can be obtained by decreasing the size of the pixels, that is to say, the resolution. Think, Write, Share. What is an array? When I say it is an array of individual pixels, what does that mean? While full color will be addressed in the next lesson, an important idea here is that images on computer screens are created with light by illuminating pixels on the screen. This is why it is typical in a black and white image for the value 1 to represent white. It means turn on the light, and 0 represents black. Light off. So if you're drawing on paper, you might do the inverse. If you're mixing paints in an art class, the more paint you mix up, probably the darker your color you're going to get. I guess depending on the colors there. So the opposite is true in terms of light. The more lights that are on, the brighter it is. No lights, no bright. And if you didn't know what the word pixel means, it's short for picture element. This is the fundamental unit of a digital image. Typically, this is a tiny square or dot that contains a single point of color of a larger image. So here's some questions, first 3 and then one more, for you to answer while completing the puzzle of the day. So what information will need to be included to reconstruct the image? So you'll answer this. This will be step 1 in your protocol in encoding black and white images. Step 2 would be how will that information be represented in binary? And then ignore this first sentence. Is there any aspect of your encoding that is ambiguous or could lead to improperly structured images? Could you include more information in your encoding to solve this problem? Will your encoding scheme work with this larger image right here? So what we've discovered is that the data of our image file must contain more than just a 0 or 1 for every pixel. It must contain other data that describes the pixel data. This is called metadata. In this case, the metadata encodes the width and height of the image. So let's take a look at this puzzle here. After clicking the link or typing in the link, you'll be on this page here. And so you can just kind of experiment, start typing and see what happens. And then definitely go back, there's the hexadecimal, then go back to the questions here in the video to answer and thus create your black and white image protocol. Attempting to communicate with possible intelligent life beyond our solar system has been a dream for humans and the goal of scientists for many years. Questions about messages to send, as well as how to send messages deep into space to unknown recipients, have been debated. In 1974, scientists sent the Arecibo message to the star cluster M13, some 25,000 light years away. Read about the message they sent using 1600 binary digits at this Wikipedia link. How would you change the content of the message? What would you delete and add? Why would your change be significant in a communication to other intelligent beings? So I took the image from the article and pasted it right here to the right. Here's a Think Right Share to go along with it, and then in just a moment I'll go ahead and go to the Wikipedia page with you and show you around. So how would you change the content of this message? What would you delete or add? And why would your change be significant in a communication to other intelligent beings? So right here, that's the message we're sending out. Now let's break down the message a little bit more. If I jump over here to the Wikipedia page, you'll see here that there's an explanation. So first it talks about the numbers. This is the numbers part. This is the DNA part, the purple. Then you got nucleotides, and then the double helix of our DNA. There's a picture of a human. There's our planets in the solar system, starting with the sun, obviously. We have a telescope that is sending the message. And right here was really interesting. It said the Arecibo message as decoded into 23 rows and 73 columns. Although unintelligible, the message in this format appears sufficiently organized to show that it's not a random signal. So if there's intelligent life out there, and they're half as intelligent as us, they can hear or see the signal and understand that it is not random space noise, that there's a pattern, a meaningful pattern to it. So a little more details to that pattern. Dr. Frank Drake, then at Cornell University and creator of the Drake equation, wrote the message with the help from Carl Sagan, among other people. The message consists of 7 parts that encode the following. First, we tell them about our number system, the numbers 1 to 10. The atomic numbers of the elements come next, and this is for hydrogen, carbon, nitrogen, oxygen, and phosphorus, which makes up our DNA. The formulas for the sugars and bases and the nucleotides of our DNA, the number of nucleotides in DNA, and a graphic of the double helix structure. A graphic figure of a human, the dimension, that is their height, of an average man and the human population of Earth. A graphic of the solar system, indicating which of the planets the message is coming from. And a graphic of the Arecibo radio telescope and the dimension. That's the physical diameter of the transmitting antenna dish. Of all of these, I kind of find number 5 the strangest. But how does this binary message work? So first off, it's just showing the numbers. So in binary, it just goes 1, 2, 3, and so on. Then using those numbers to represent the atomic numbers of the elements which make up DNA, calling it carbon would make no sense, but saying it has 6 protons should be universal. Carbon here on Earth will still be carbon there out in the galaxy. Then combine the elements and make chemical formulas for the molecules in DNA. Let me show you the Wikipedia page, which I just finished, but it's worth your time to go ahead and look through there on your own. Now that you've looked at how complex that Arecibo message is, well, it's complex and it's not complex. I have a much simpler binary problem for you to try to figure out. So let's go to this website, click the link. Okay, and now do not look at this next slide unless you're ready to see the answer. So this is a little puzzle. You're going to see it's jumbled, but what you want to do is make a C in the middle, just like this. So don't look at these numbers unless you're ready for the answer. After spending some time trying to figure out how to make the C, because it's only off by a single bit, after spending some time trying to figure that out, you can look over here to see the answer, and if making it a hexadecimal number helps you, there you go. So that should have been a fun brain teaser for you, figuring out which bit was off and then correcting it. Our last Think Right share of the day is this: of those 7 pieces of information, which would be the most important for the aliens to understand? I said that number 5 was the strangest to me, the fact that it's just a lot of information about us humans. Okay, so of the 7, and you can go back to see 7 here, which one, if you just chose one to send to aliens, to intelligent life, which one would it be and why? And if you want to learn more about this, video on YouTube from the SciShow is pretty interesting. Arecibo information starts at the 327 mark, but if you just type in 3 messages we've sent to extraterrestrials, you should be able to find it pretty easily. So here's the DOL, how are images made using the binary system for bits. Don't forget to use the vocab we learned today.